Hello students, Deepak Pandey here. A very happy new year to all my students and to all those who are following these lectures. I hope this new year brings you a lots of positive energy and confidence so that you can prepare well for the upcoming examination. So in this video, I am going to discuss how to find the Laplace transform of custom functions or some problems based on graphs, as many of you have requested to cover this section. So let us discuss as far as GATE point of view is concerned. In GATE examination, there is no need to solve the problems of Laplace transform by the basic definition. I hope all of you understand that what is the basic definition of Laplace of a function of time. So there is no need to solve that complex integral. Most of the questions are based on the properties of Laplace transform. In this lecture, I am going to discuss a particular section. Okay, so let us start. First of all, I have to explain here that what is the meaning of UT. UT is called unit step input. So mathematically, what is UT? If we explain it mathematically, for t less than 0, the value of this function is 0, and for t greater than 0, the value of this function is equal to 1. So this is the mathematical description of the function ut. Fine. It means that before time t equal to 0, the value of the function was 0, there was nothing, and after time t equal to 0, the value of the function is equal to 1. Fine. Based on this, if you explain ut minus 1, what is the meaning of ut minus 1? Based on this, you can say that for t less than 1, the value of the function is equal to 0. For t greater than 1, the value of the function is equal to 1. Right? Similarly, let us also take ut minus 2 and let us explain it mathematically as well. So t less than 2, the answer is 0. T greater than 2, the answer is 1. Okay, so I hope you get this point, that how to understand the unit step input ut, ut minus 1 and ut minus 2. Now let us write what is the mathematical description of ut minus 1 minus ut minus 2, right? So ut minus 1 minus ut minus 2. So first of all, let me write the time intervals here. I'll be having the following time intervals: t less than 1, t less than 2 but greater than 1, and t greater than 2. Right? I'm not using the equality signs here. At equality signs, there will be discontinuity. Right? So t less than 1, let us see the value of ut minus 1 for t less than 1. For t less than 1, ut minus 1 is 0. So 0 minus, for t less than 1, what is the value of ut minus 2? For t less than 2, the value of ut minus 2 is 0. So for t less than 1, the value of ut minus 2 is also 0. Sorry. So 0 minus 0, it becomes 0. Clear? When t is between 1 to 2. Okay. So t is between 1 to 2 means t is greater than 1. Okay. And less than 2. So what is the value of ut minus 1 when t is greater than 1? The answer is 1. Okay. What is the value of ut minus 2 when t is less than 2? So when t is less than 2, the value of ut minus 2 is equal to 0. So 1 minus 0 is equal to 1. So just find the values of ut minus 1 and ut minus 2 in the following intervals. So for t greater than 2, what is the value of ut minus 1? 1, right? So for t greater than 1, it is 1. So for t greater than 2 also, the value must be equal to 1. So 1. What is the value of ut minus 2 for t greater than 2? For t greater than 2, the value of ut minus 2 is also 1. What is 1 minus 1? Right? So at this point, I am getting a very interesting result. See this. When time is less than 1, answer is 0. When time is between 1 to 2, answer is 1. When time is greater than 2, answer is 0. So suppose if I multiply ut minus 1 minus ut minus 2 by anything, by a quantity. Suppose a person x gets multiplied by ut minus 1 minus ut minus 2. What does it mean mathematically? You know that the limits will be t less than 1, t less than 2 greater than 1 and t greater than 2, right? The value for t less than 1 is equal to 0. 0 multiplied by this person becomes 0. Between 1 to 2, the value of this entire expression inside the bracket is equal to 1. 1 multiplied by the person becomes the person itself, right? And for t greater than 2, the value is again 0. And 0 multiplied by the person gives you 0. This explains a very, very important use of the unit step function. Suppose you want to write mathematically, not literally, but mathematically, right? You want to write that something is happening between time t1 to time t2. Before time t1, the value is 0. After time t2, the value is 0. But something is happening between t1 to t2. So how to write it mathematically? Using unit step function. Very easy to write. Learn the trick, learn the method. You want to say that something has happened between time t1 to t2. So how to write it? Something multiplied by u of t minus t1 minus u of t minus t2, just like this. If something has happened between 1 to 2, how to write it? Something multiplied by ut minus 1 minus ut minus 2. Getting my point? If you multiply this function ut minus 1 minus ut minus 2 by some function of time, suppose, because we'll be dealing with function of time in Laplace transform. Very, very important utility of unit step input. No books, no text are going to explain this, and if you use this method, then you'll be able to solve the problems in GATE based on Laplace transform. But yes, let me explain you that Laplace has very less weightage in mathematics, most of the time 1 mark, and many times you can observe yourself that there are no questions on Laplace. So do not waste time on finding the Laplace of some random kind of curves. Just learn the trick, follow some standard, solve some standard problems, and that's it. The topic is done. Do not spend more than 1 hour or 2 hours on this topic, right? You have other important topics as well. So ft into ut minus 1 minus ut minus 2, it means that for t less than 1, the answer is 0. For t less than 2, greater than 1, the answer is ft. For t greater than 2, the answer is again 0. So I hope this explains easily that how to write something mathematically when the something is happening between time t1 to t2. Now this is going to help you to find the Laplace of various graphs for various custom inputs, right? But before that, let me give you the Laplace of some basic function. I hope you know these things. Laplace of ut is equal to 1. Laplace of mut is equal to m. I'm sorry, this should be 1 by s and this should be m by s. Okay. Laplace of u t minus 1. Now how to find the Laplace of this? I think you must have read the second shifting property, which is also called the translation theorem. This should be written as e raised to the power minus a, which is 1, so minus s by s. And Laplace of ut minus 2 is equal to e raised to the power minus 2s by s. Laplace of tut. Now how to find the Laplace of this? You can use the property of multiplication by t. You know the Laplace of ut, it is 1 by s, multiply by t, differentiate the Laplace. So I think you have read these properties. So what is this? 1 by s square. Fine. What is the Laplace of t minus 1 ut minus 1? Use the translation theorem. This should be e raised to the power minus s by s square. What is the Laplace of t minus 2 ut minus 2? Again translation theorem, but the value of a becomes 2. So e raised to the power minus 2s by s square. These are some basic Laplace transforms which will be used in solving the graphical problems on Laplace transform. Let us discuss some problems on graphical Laplace transform. The first problem I'm taking from GATE only. This value is 1, this is 2, or let us keep this as 1 and this as 2, and then it goes up to infinity, right? We have to find the Laplace of this transform. Let us take another problem simultaneously. So this value is minus 1, this is plus 1, this is time axis 0, 1 and 2, right? So these two problems, I will explain them by using the unit step input, right? No need to solve this problem by solving the integral. It is going to take more time, and there are more chances that you are going to make mistake if you solve these problems by solving the integral, because while putting the values of upper limit and lower limit, most of the students do calculation mistakes. Fine. Now how to write this? First of all, you find the equation of these two lines. Definitely these two lines are having different equations. What is the equation of this line? Ft is equal to 1. What is the equation of this line? It is a straight line, right? Passing through origin, having slope y by x. So slope is 1 by 2. Okay. So what is the equation? 1 by 2 into t. Now, this equation, this line is present between time t equal to 0 to time t is equal to 2. And this horizontal line is present between time t is equal to 2 up to infinity. So how to write it? First of all, you learn how to write f of t, right? Suppose this is f of t and this is t. Let me call this as f2t and let me call this as f1t. Okay. So how to write f of t? First of all, this equation, which is t by 2. Now think about what is the limit of x time up to which this equation is existing, right? This equation exists from time t equal to 0 to time t is equal to 2. So I just explained how to write it mathematically. I hope you understand this. So u t minus 0 minus u t minus 2. Getting my point? So this thing exists from 0 to 2. After 2, this thing is not present. Before 0, this thing is not present. So before 0, there is nothing, but after 2, there is something. So let us write about that. What is there after 2? It is 1. So let me write here 1. Okay. And 1 is present from 2 up to infinity. So you should write this as u t minus 2 and leave it as it is. Don't write minus u t minus infinity. There is nothing. It means that something is present after time 2 and then it is always present. So there is no need to write ut minus infinity. Okay. Now, if you open these brackets, you are going to get t by 2 ut minus t by 2 ut minus 2 plus ut minus 2. Okay. Now you know how to take Laplace of t ut. I just gave you the formula. Should be multiplied by 1 by 2. 1 by 2 is a constant. There is no problem. How to take Laplace transform of ut minus 2? You know the Laplace transform of ut minus 2. Use the multiplication property by t. And what is the Laplace of ut minus 2? I just gave you the expression. You can write this as Laplace as ft, and in the next step, what is the Laplace of ft? That can be easily written. Okay. So just try to write the final solution of Laplace of this ft expression. Okay. So you can also solve this problem by rearranging these t minus 2 and t ut minus 2, u of t minus 2 terms. So before taking Laplace, let us rearrange it also. You can also use the multiplication property. Whichever property you find comfortable, whichever method you find comfortable, you can use, right? So what is the Laplace transform of t by 2 u2? I hope we know this Laplace transform. You know this very well. So you can always use here. What to do about this? Okay, first of all, let me take 1 by 2 constant. So we'll use this 1 by 2 symbol later. So now this becomes tut minus t ut minus 2 plus ut minus 2. So let us take this ut minus 2 common. So what is left here? I think it is t minus 1. So minus t ut minus 2 plus ut minus 2. Okay. This is the thing for which you have to take Laplace. Now while taking Laplace, please note that you can use the translation theorem only if t minus 2 and t minus 2 are same. Either it should be t minus 1 ut minus 1 or it should be t minus 2 ut minus 2. Okay. So to make it t minus 2, you can write here t minus 2 plus 1. And then this can be opened. definitely it is going to take 2 or 3 steps. So you can directly use the multiplication by t property here. Both properties are applicable. Okay. Now this gives you 1 by 2 tut minus t minus 2 ut minus 2. Clear? Just check the calculations here, and this is going to become minus ut minus 2. Okay, so I hope the calculations are fine. You are trying to make in this expression, you are trying to make t minus 2 ut minus 2. Then only you can apply the translation theorem. This is going to give you 1 by 2. What is the Laplace transform of t ut? 1 by s square. This is t minus 2 ut minus 2. So this becomes e raised to the power minus 2s by s square minus ut minus 2, and that becomes e raised to the power minus 2s divided by s. That is the Laplace transform of this final expression. I hope the method is clear to you. Just write your graph in this form. Thereafter, it's up to you. You use the direct property if you find yourself comfortable in that. Otherwise, try to make these results. Like if you want to write here, suppose it was t ut minus 2, I have to make t minus 2 here as well. Do not try to change this t minus 2. You can make the problem complex. So just write here t minus 2. So I took the things common, then it became t minus 1. So instead of writing minus 1, I wrote minus 2 plus 1. Okay, now let us come to this problem. This one is quite easy to solve, and definitely you can also solve it by solving the basic integral by using the basic definition of Laplace. What is the equation of this line? Ft is equal to 1. What is the equation of this line? Ft is equal to minus 1. Now if you want to write here Ft, you can see that the equation 1 lies from 0 to 1 and the equation minus 1 lies from 1 to 2. So how to write it? Ft is equal to 1 into ut minus 0 minus ut minus 1. Clear? And then minus 1, so plus minus 1, or you can directly write minus 1, which is from ut minus 1 minus ut minus 2. See how easily you can write this expression. Now you want to take Laplace. This one is quite easy to solve. You can directly take Laplace here. So what is the Laplace of ut? It is 1 by s. Laplace of ut minus 1, e raised to the power minus s by s. Laplace of ut minus 1, e raised to the power minus s by s. Laplace of ut minus 2, this minus minus becomes plus, so e raised to the power minus 2s divided by s. So 1 by s you can take common, and then you have 1 minus twice of e raised to the power minus s plus e raised to the power minus 2s. You can also write this as 1 minus e raised to the power minus s whole square divided by s. So I hope these two problems explain very clearly how to approach for the problems where Laplace is being asked in for a custom input, right? For graphical kind of questions. Okay, so if you have any kind of doubt in solving Laplace of graphical problems, you can always ask in the comment section. Okay, thank you very much.